This is 4.5b, probability quick review. So instead of moving on to the next section, since we have a lot of things we've learned about in this probability section, we want to just review them real quick before we go on. So how many outcomes possible if I roll 4 dice? Okay, notice I'm not telling you which type. Before in the notes and the homework, we always said, well, do this, now this, now this, now this, and gave you very specific ways to go through all the problems. Now it's within the question, you have to figure it out. So right here, it's how many outcomes. That's the key thing. If you see something that asks for how many outcomes, that is the counting principle, the fundamental counting principle. Okay. Oh, that's the wrong principle. There we go. So how many outcomes possible if I roll 4 dice? So if I have 4 dice, that means I have 4 categories or things that I'm going to be dealing with. So 4 blanks. And then on those blanks is how many outcomes I have from each thing. So if it's a die roll, I have 6 times 6 times 6 times 6, because each die has 6 sides, so I have 6 options. So I multiply those all together, and I get 1,296. And there it is. Example 2, how many outcomes? Oh, there we have it again. Right away, I don't even have to think about it. I know I'm using the counting principle. If I draw 3 cards with replacement, so I have 3 categories, 3 cards, and within each category, I have my number of outcomes. With replacement is important because that means we have to put the card back, so it's not going to go down every time. It should be the same. So in a deck of cards, I have 52 cards. There are 52 outcomes for each card draw because it's with replacement. If it was without replacement, remember we'd be going down each one because I'm missing a card each time. So this is going to be a lot of outcomes. And when you multiply those together, you do indeed get a lot. 140,608 outcomes. Which is why, if you remember when we're talking about drawing specific cards, even face cards or non-face cards, which there's a lot more of those in the deck of cards, it ended up with a low probability with 3 cards because there are a lot of outcomes possible. Okay. So example 3, find the probability. Okay, we've switched it up. This is going to be finding the probability, so we're going to have to find the probability. So probability, remember, is fractions, decimals, and percents. So we're going to be dealing with fractions, decimals, and percents. So these questions, it's not just a counting principle. We're going to use similar ideas, but we got to deal with fractions now. If I draw 2 cards, so I'm going to have 2 fractions, with replacement, so that means putting it back, I want an ace and then a face card. So 4 out of 52 for the ace, 12 out of 52 for the face card. It doesn't change because it's with replacement. Pay attention to that. So I multiply them. I use a calculator. 4 divided by 52 times 12 divided by 52, and I get 0.018. Remember, move the decimal twice to the right and write it as a percent. That's usually how I do it because I like percentages. I can understand percentages better or best because it's easy for me. I know 0 is the lowest, 100 is the highest, so close to 0, like this one, is a really low probability. Example 4 says a factory has 4 defective parts in every 18 parts. Probably going to be some sort of probability. An inspector selects 3 random parts. What is the probability? Okay, so this is like the last question. They're all defective. Okay, so we got to think of the situation now. If you have a factory worker who's inspecting things, if he inspects one of them, is he going to put it back and inspect that same one again? No, he's going to use a different batch, a different thing. So without even it saying, we need to notice, thinking about it logically, using some critical thinking, this is without replacement. The factory worker is not going to check the same part 3 times. Okay. Think about a random sample. Even if he's randomly sampling, right, he picks 3 values, 3 part numbers or something like that, and those are the 3 he picks. He doesn't pick the same one 3 times. Okay. A factory has 4 defective parts for every 18, so that's going to give me my fraction. we're selecting 3 parts, wrong color there, and we want them to be defective. So 1, 2, 3, all 3 are going to be defective. So 4 out of 18 defective parts first. Then I go down the line, so I have picked one. It's gone. So that means my defective parts and my total number of parts has gone down, right? Don't forget, we assume we completed that first task. So we assume we got a defective part the first time. Now I look at the second part. Once again, we assume it is defective to be able to go through these probabilities. So it's 2 out of 16, because these probabilities are actually getting lower each time. If you actually calculated the percentages, they're smaller and smaller each time, because we're lowering the amount of odds of getting those defective parts. So we multiply them and we get a very small probability. Move the decimal twice to the right, and it's still 0 in front, so it's 0.5%. Very small probability. It's very unlikely that he would pick 3 defective parts. Example 5, which is also our last example, but it has parts A, B, C, D. There's 4 parts to this. So we have a spinner with blue, red, white, and yellow sections. Okay? And a die numbered 1 through 6 are used in an experiment. Notice all of these are asking for a probability again, but we're going to mix it up. So some of them have or, some of them have and. And you have to think multiply. Or, if you remember from our last set of notes, I'll actually go to it so you can see it. When we talk about or, it's the addition rule. So we're using this whole string every time the word or happens. So when I see or, I'm thinking addition. Okay, but remember, we have a rule for that. Multiplication, we don't really have a rule for it, right? We just kind of think about the scenario, multiply it out. It's what we've been doing. We will add in combinations to multiplying eventually, so these questions will get a little more tough at the end of the chapter. But or, we have an addition rule. So don't forget the addition rule. All right, so the first and says, what is the probability of getting a blue on the spinner and a number less than 5? Okay, so it's multiply. So I'm having 2 things that I am multiplying together. First is blue on the spinner. That's the first part. So if I look at the spinner and think, well, I have 4 outcomes possible. One of them is blue. 1/4 chance of getting blue. The number less than 5, so I have 1 through 6. So what numbers are less than 5? 1, 2, 3, 4. Okay, those are the only numbers less than 5, so it's 4 out of 6. And then I multiply together 1/4. 1 divided by 4 times 4 divided by 6. 0.167. Convert to percent, and I get 16.7%. It's a little bit higher than the probabilities we've been dealing with, but there we have it. Now we get to an or question, so it's the addition rule. So remember the addition rule. You take the probability of the first one plus the probability of the second one, so probability of yellow plus the probability of odd, minus the probability of both. And notice, we actually have an and. We've talked about how to think about this, but we're going to see that you can actually just multiply to get that and. Okay, we have to think, are they mutually exclusive? Can I get yellow on the spinner and an odd die? If I get yellow on the spinner, I can roll any number on the die, so they are not mutually exclusive, meaning they can happen at the same time. So this will be a probability, okay? So start off with yellow. That one's easy. How many sections? I have 1/4. One yellow section out of the 4 possible outcomes. Plus odd. Okay, so my odd numbers are 1, 3, 5, 3 out of 6. Minus the probability of yellow and odd. Okay, so pay attention to this. Probability of yellow and odd, we can actually use the multiply idea we just did, right? So and is multiply, yellow is 1/4. times odd is 3/6, which equals, multiply the tops and I get 3, multiply the bottoms and I get 24. 3/24 is the probability of getting both yellow and odd, right? We just did that exact same idea with the previous example. So these questions, the addition rule questions, are actually the harder ones for most people because you have an addition, you have a subtraction, and you usually, unless they're mutually exclusive, have this and to deal with. Sometimes you can think about it logically. This one's not super easy to think about logically, so we use multiply. And means multiply, so we can do multiply just this one piece and get that piece. Now, we type this whole thing in our calculator. 1 divided by 4 plus 3 divided by 6 minus 3 divided by 24. And you get a pretty big probability. So I move the decimal twice to the right, and I get 62.5%. Done. Okay. All right, we have another OR. So once again, you see OR, you think addition rule. Okay. So we have the probability of not white. That means anything other than white. It's the complement of white. Anything other than white. Plus the probability of a number less than 3. Once again, these are not mutually exclusive. They can happen at the same time, so we are going to have to subtract not white and less than 3. Hard to fit all of that. There we go. Okay. So go through each probability. Not white. So which colors are not white? Well, blue, red, and yellow. 3 out of the 4. One of them is white. Plus number less than 3, 1 and 2, 2 out of the 6. Minus the both of them. So in this case, it's kind of hard to think, all right, how many times does not white appear and a number less than 3? But remember, and we can multiply. So 3/4 times 2, 6. Just multiply the top, 6, multiply the bottom, 24. I'm not simplifying because we're just going to use, I'm not getting a common denominator. We're using calculators. Use your calculator. Okay, so you get even bigger probability. You'll notice that the ORs, the addition rules, usually end up with larger probabilities because either one will work. Where with ands, they both have to be there for it to work. So ands usually have smaller probabilities, ORs usually have bigger probabilities. And we get 83.3%. We move the decimal. Okay. And the last one, it is an and again. Okay, so we're thinking multiply. Notice how these are getting more complicated because we have more things to think about. All right, so I have two things that I'm going to multiply together. Red and white, or sorry, red or white. So if I get red or white, that first one is there, so that's 2 out of the 4 options. If I got blue or yellow, that wouldn't work, so that's why it's 2 out of 4. And a number greater than 5, well, I mean, it's not super exciting, and there's only one number greater than 5, which is 6. So it's only 1 out of 6. And so we multiply, and once again, you see, you get a lower probability. The ands usually give you a much lower probability because both have to, and means both have to occur for it to work. Or means one or the other. Either thing occurs and it'll work. Okay, and that's that. So that's our little quick review. Write your 3-sentence summary.